Let's start recording. Let's do this thing. First one was 17. Write as repeated multiplication and in standard form. So I went over the lesson before, just so we remember. Repeated multiplication is just the base, whatever the base is, multiplied by itself again and again, and however many times the exponent's there. And then standard form or evaluated form means just do the math, multiply it together, tell me what it is. And I told you could use a calculator for this stuff. Was the video tutorial helpful for different calculators? Okay, were there any calculators that I didn't address that any of you have questions about? I think I could try to cover all of them, but obviously it's a video that doesn't take into account you in my class now, just a year ago. Okay, cool. Hearing nothing, I'm gonna move on. 17. So, like repeated multiplication, that's just gonna be 4 times 4 times 4. Standard form is gonna be 4 times 4 is 16 times 4 is 64. So the first one I think is easy. The next one is where things get a little dicey, but I did examples like this in class. What's the base on this question? It's 4, not -4. There's no brackets. And exponents happen first in BEDMAS. So it'll be 4 to the 3, so 4 times 4 times 4, and then this minus means there's a times -1 out front. In this one, what's the base? Where's that exponent? Is it inside the brackets or outside the brackets? It's inside. So what's the base? It's just 4. It's a tricky one. If it was on the outside, it would be -4. But because it's inside, we have to look here and say, okay, well, inside the brackets, I've got 4 cubed times -1. But at the end, it doesn't matter because I'm multiplying by -1 again. So this thing, as repeated multiplication, is going to be -1 times -1 times 4 times 4 times 4. Which is still just going to be 64. You understand what I mean by that, or would it help you to write it for me to write it down? Okay, so that's just this one up front is going to be -1 times -1 times 4 times 4 times 4. And then this one is actually the same as this one because that 3 is located inside the brackets. The base is still just 4. And that -1 multiplies up front. These two are exactly the same. Which products are positive? 1 and 3 are positive. Which products are negative? 2 and 4. These ones, same idea. Carmen, does that help with 17? Does that make sense? Okay, is there any? Okay, so I can move on? Okay. Oh. No, if you're explaining something, that's cool. Were you done explaining to your friend? Or to whomever? I don't know who you were actually explaining it to. You were just pointing and talking. We're good? Okay. Number 20. Yes. For which one? Yes. Yes. I don't think I assigned 15. Okay, so it's just about stamps. It's a word problem with stamps. How many stamps are in a 3x3 block? I'm assuming 3x3 is just like a standard piece of paper, but made up into stamps. So 3x3 is just no, I did not assign this. She's asking about it. 3x3 means there's 3 stamps like this, times, and then the whole page is divided into stamps, but 3x3 means it actually looks like this. So it's a square, or in this case a rectangle, made 3 stamps this way, 3 stamps this way. The area, or the number of stamps, is just going to be the number in the rows times by the number of rows. So this is going to be, basically all they wanted you to say was 3 squared as a number of stamps as a power. Well, it's 3 squared. That was it. And then the value of the stamps, it's 3 squared times $1.55. Which 9 times $1.55. So that was it. And that was the same idea with B. I just didn't want, I was just convoluted and I didn't want to bother. I don't want to bother you guys with such a convoluted question. I added 20 and 21. Carolyn had, you said she wanted to see these. These ones, these are good. I like these kinds of questions, and this is actually going to be useful for us to do in the future. This one said to write out each number as a power with base 2 and to explain your method. I care less about the explanation for this one than I do about you actually doing it, but I wasn't here to say that. So basically what I mean by that is I want you to write each of these numbers as 2 to some power. So 4 is 2 to the power of what? 2. Okay, cool. 16 is 2 to the power of? 64 is 2 to the power of? 256. Oh no, this is the easier one. 128 is 2 to the power of? This is going to be 2 to the power 5, because then 16 and 32. 16 times 2 is 32, so that's just going to bring us up there. 64 times 2 is 128, brings us there. And then 128 times 2 is 256. So that's going to give us 2 to the 8. So the questions were given to you purposefully out of order so you don't see the pattern, but if you were... Well, it's a good thing you didn't explain, because I didn't want you to, and if I'd been here, I'd have crossed that up. My apologies. And then, so then 21 was the same kind of idea. Write each number as a power in as many different ways as possible. So 64 is 2 squared. Sorry, 2 to the 4. It's also 4 squared. 81 is 9 squared. It's also 3 to the 4. 256 is 2 to the 8, which is also 4 to the 4, which is also 16 squared. Yeah, thank you. So that's just what I wanted you to do for 21. That's going to become a useful technique for us later on. That was it. That was what I asked you to do for homework from that section. Comments, questions, concerns on this? And then Mrs. Thiessen yesterday said I told her to give you about a half hour to work on this. And then to take a look at this video. This is just bed mass, which you guys, this page should have felt like it was review from grade 8. Did it feel like review, or was it all brand new? Good, because it was supposed to be review. Were there any questions about anything on here? I mean, this video was really short. I went through it pretty quick, but it's also only one page. And then I wanted you to do, I was hoping she would get you guys to, because there wasn't, I didn't think there was that many questions. I mean, I guess there's kind of a lot of questions. Did anyone do this for homework anyway, even though she didn't assign it? You did most of it? Okay. I want to double check what's going on today. Okay, here's what I'm going to do. I'm going to leave the bed mass stuff. I'm going to do today's lesson. Today's lesson is not very long. It's pretty quick. And then I'm going to get, so I want to get that done, and then I'll give you all the rest of class time to do. If you didn't do the bed mass homework, you'll have time to do the bed mass homework, and you'll have time to do the exponents a lot like this lesson 3 homework, if that's, well, I mean, I say if that's okay, but I don't really care if that's okay, because that's what I'm going to do. So if that stresses you out, I apologize, but I would like to try. Just get this particular lesson done. I don't think it should be terribly hard. I think you'll understand it pretty good. I would like, what I'm trying to do is I would love to get this unit done by March break, which is not a lot of time. So we'll see what happens. So here we go. Because I don't want you to have a 2-week break in the middle of a unit, which would suck. So here we go. Let's do this. Flip to this page. Lesson 3, Exponent Laws, Part 1. We're going to, actually, let's look at this first one. Which of these powers have the same base? Identifying what the bases are is important. Look at this top row here. Which of these powers have the same base? Anyone, hands up, give me a pair. Harwin, is that a hand, or are you pointing, kind of thinking in your head? Okay, Kyla. 8 to the 5 has the same base as what? As also, what else? There's 2 more for A. 8 to the power of 3, and we could technically loop 1 more in there. Yeah, in the bracket though, this means both of them are the base. So I guess depending on how you write it, you're going to see that eventually you're going to see that we can rewrite it like this. 3 to the 6, a to the 6. I haven't shown you that yet, but you're going to see it. Maybe you saw it last year with the exponent laws because you were supposed to do exponent laws in grade 8. Did you see this one? Okay. If you didn't see it, that's okay. I'm going to show it to you eventually. So that's technically part of the same base too. Are there any other, like, group me some more? Yeah, Rebecca. Okay, any other ones? Angel, sorry. 7 to the power of 6 is the same as? You betcha. So those two, and then the 5 cubed is on its own. Okay, fantastic. There are some laws in exponents that take advantage of other mathematical operators to simplify how they're allowed to work. And so this is a technique you're going to learn all through your math career. You'll learn a bunch of things that are a little bit more complicated, and then you'll learn laws to shrink things down. I had a student come in here, well, a calculus student, she was in here last block, and she said, I hate all the laws. And I said, okay, fine, well then just use the definition. Which is, so she's doing something called derivatives. You're going to learn eventually that there is a single law that covers all of what's called differentiation, which is a math technique you'll learn about later. The definition is ugly and gross, but you can use it every time. It always works, but it's awful to use. So there's a whole bunch of laws that once you learn, you don't have to go back to the definition, you can shortcut them. She's like, there's too many. I don't want to memorize them all. But memorizing them all saves you a ton of work later. So there's 6 or 7, maybe 8, depending on how I break them up, I can't remember, of these exponent laws that I want you to get comfortable with. Some of them you should have learned in grade 8. The first one is called, it involves multiplying powers with the same base. When you do this, you are going to add exponents. I'm going to prove to you why this works. So, here we go. If I have 2 cubed times 2 to the 4, what does that look like as repeated multiplication? Carolyn? 2 times 2 times 2, that's the 2 cubed, times 2 times 2 times 2 times 2. Are we cool with this? I just wrote 2 cubed is 2 times 2 times 2. I have 2 to the 4 as 2 times 2 times 2 times 2. But I'm just multiplying 2 times 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 2. How many 2's are there? I'm not sure if I said 7, but there are 7 written on the page. So this is just 2 to the 7. But look at what happened here. What can I do with the exponents then? I just add them. So what this means is this is the same thing as 2 cubed. I can add my 2 exponents together. It's 2 to the 3 plus 4, which I can rewrite as 2 to the 7. This law has a name. We call this thing a product of powers. And this thing only works when what is true? Yes. When the base is the same. Okay, cool. So must have same base. Hands up if you saw this in grade 8. Few of you did, which means the rest of you are forgetting. Love it. In general, because I'm going to start bringing in exponents, I'm going to give this to you. What this means is, or it's not exponents, because we're going to deal with variables, we can write this as x to the m times x to the n is going to equal x to the m plus n, where as long as m and n are, as long as x, well, x is just x. As long as that value is the same, my bases are the same, I'm allowed to add my exponents. So 3 squared times 3 to the 5 is going to be what? 3 to the 7. This one's going to be 7 to the 8. This one's going to be 4 to the 11 times 3 squared. Good. Those exponents, those bases are different, so I cannot group them. Love it. So that's how you leave it. Yeah. Yep. Because the instructions say to simplify and leave in exponential form, we're done at that point. If I said evaluate, you'd have to pull out your calculator because I don't know what 4 to the 11 is, and I would not expect you to do that longhand. Okay, so that's the first one. That should not be new to you. The next one, dividing powers with the same base. You're going to see here that we can subtract exponents. So I have 4 to the 4 divided by 4 squared. I'm going to rewrite that thing as a fraction. 4 to the 4 over 4 squared. Well, this thing, 4 to the 4 can be written as what? Oh, crap, I should have written that in red. Oh, well. 4 to the 4 can be written as? No, that's 4 times 4 is 16. And I want it repeated multiplication. 4 times 4 times 4 times 4. And 4 squared is just 4 times 4. Right? Can I simplify this at all? Not yet. I'm multiplying a bunch of 4s, but then I'm dividing by a bunch of 4s. So if I have a 4 in the numerator and the denominator, this fraction just represents division. I can just look at this and say, because all I've got is multiplication and division, I can say, well, 4 divided by 4 is 1, so those cancel. 4 divided by 4 is 1. So that what I'm left with is 4 times 4, which I can write as 4 squared. Yes, you can write that as 16, but don't. I want to keep everything in power form. So how could I have done this instead? I think someone over there, one of you guys on the side said it. I can't remember which one of you said it. When I'm dividing, I can just subtract the exponents. Because we can see here, this is the longhand is they cancel. In short, if I have 4 to the 4 over 4 squared, this is the same thing as 4 to the power of 4 minus 2, which is 4 squared. And it's always, 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 when you're dealing with these things, top exponent minus bottom exponent. It doesn't matter if that gives you a negative number. I'll show you how to deal with negative exponents later. It's always top minus bottom. And again, you also have to have the same base here. Just like before, we need the same base. The previous law was called a product of powers. Does anyone have a guess on what this one would be called? Sorry? What do I call the answer that I get when I divide? Sorry? Louder. Was that Angel or was that Kyla? Or was it Aminette? It's a quotient. So this is going to be a quotient of powers. I'm going to write that in red because I want to be alternating colors here. A quotient of powers is what this rule is called. And so in general, how I can write this, if I have x to the m over x to the n, that's the same thing as x to the power of m minus n. That's a subtraction in there, not multiplication. This one should also technically be review. Hands up if you've seen this one before. Okay, so a bunch of you have seen it, and a bunch of you have forgotten. I really hope it's forgetting. So, yeah, Kyla.
What do you do on the base of that?
Nothing. You do nothing. You leave them as they are. So if I have something like this, 8 to the 5 divided by 8 squared, what's that going to be in exponential form? Simplify it. It's going to be 8 to the 3, because 5 minus 2 is 3. When I've got 12 to the 6 divided by 12 to the 4, that's going to be 12 to the... Good. If I have 6 to the 3 divided by 4 to the 3, that's going to be... It's just going to be 6 to the 3 divided by 4 to the 3. I cannot make a simplification there because they are the same. They are not the same. They are not the same. The words are important. As a note, if there is no exponent there, what is the exponent that we assume is there? This is x to the power of what, if there's nothing written? 1. Thank you. And I've already shown you anything to the power of 0 is 1. Okay, cool. So using these two exponent laws, what's this one going to be? 2 to the power of what? 13. Yes. Why 13? Because when I multiply the same bases, the exponents add. So 4 plus 8 is 12, plus 1 is 13. What about this question? It's going to be x cubed. Why is it x cubed? Because x, if there's no exponent written, we assume the exponent is a 1. So this is going to be 2 plus 1, which is 3. So it's x to the power of 3. How about this guy? What's this beast going to be here? I'm going to zoom that in a little bit so it's easier to see. That's going to be x to the power of 4. Cool. And this a to the 10 over a to the 10 is going to be a to the, which is equal to, done. Oops, sorry. I see lots of people write this answer as 0. Because like, oh yeah, 10 minus 10 is 0. Well, no, well, that's true. That's not what we're doing here. It's a to the power of 10 minus 10. So it's going to be a to the power of 0, and anything to the power of 0 is 1. So that's making sure we're cool with how that follows is important. Again, this should all kind of be review. When there are numbers out front, we call those things coefficients. I introduced that to you last week. Bam. The 3 is a coefficient. The 5 is a coefficient. We multiply them or divide them as the question tells us. So if I have this, 3a to the 5 times 5a squared, I can rewrite this. Oh yeah, Carolyn, sorry. Yeah, 15a to the power of 7. You betcha. What's this next one? Are we cool? Carolyn's correct. Do we all understand why? Does anyone need me to blow this up or slow it down further? We're cool? Yeah, happily. So I would take this. I go 3. I can rewrite this as 3 times 5 times a to the 5 times a squared. Because it's all just multiplication. Like when I have a coefficient out front, this is the same as 3 times a to the 5 and 5 times a squared. So I can just rejig my multiplication as 3 times 5 times a to the 5 times a squared. 3 times 5 is 15. And then here, I would add, because I'm multiplying the bases, I add the exponents. A to the 5 times a squared is a to the 7. Okay. That's how you slow that down. This one is just a more complicated version of the same thing. What would I get for this beast here? How'd you get 36? 2 times 6 times 3. That's 36. And then x cubed, x to this times x to the 7 times x squared is going to give me x to the 12. So then, yeah, this is just going to be 36 x to the 12. Cool, I love it. Oh, sorry. And then I've got this guy over here. I've got 4d to the 7 over 2d cubed. I treat the coefficients like I would the coefficients. 4 over 2 is 2. And then d to the 7 over d cubed is going to be d, and then it's always top minus bottom, so it's 7 minus 3, which is? Cool. Do not flip the page. I've got a couple more examples I want to add to the bottom of this one. Let's do this guy. What if I had this? 8d to the 2 over 2d to the 5. What would this give me? Eight divided by 2 is? It's allowed to be negative. For now, it's allowed to be negative. 4 times d to the power of 2 minus 5 is negative 3. There is a rule for dealing with negatives. One sec, Danny. We will deal with negative exponents later. There will come a time, probably tomorrow, where negative exponents are no longer okay. For today, we'll allow it. Danny. Yes, you go to the bathroom? Danny.
What was that rule where you had to move the negative sign as far to the left as possible?
When the exponent, that's only when coefficients are negative. That negative is buried in the exponent. It's tied there. Sorry? Okay, guys, hold on. Please stop talking over there, because I think this is a question that I know some of you are going to need to hear this. Danny, ask it again.
Is the coefficient 4?
Yes, 4 is the coefficient. The numbers that multiply out front are called coefficients. And when you have if you had a bunch of coefficients, that some of which were negative, when you multiplied them out, that negative would go out to the front. But when you have a negative embedded in an exponent, it stays locked into that exponent, and it has a different meaning. We're going to see what that is in a day or two. What if I had this? I'll do one more. Let's say I had 6d to the 5 over 12 d to the 4. Say that one. What would I do there? Carolyn, I see that hand.
0.5.
Oh, careful. Where's 0 coming from? Oh, 0.5. Where's 0.5 coming from?
6 divided by 12.
Okay, so you got two options here. Either you do the 6 divided by 12 and you get a decimal. You could write this thing as, 0.5. Finish it, Carolyn.
And then
D to the power of 1. Whenever you have something to the power of 1, we would just write that as 0.5d. We don't actually write that exponent to the 1. Your other option, if you don't convert this thing to a decimal route, what you could have done instead, 6 over 12, if you wanted to leave that as a fraction, how would you reduce this fraction? So it would become 1 over 2, d to the 1. But this thing then is just the same as d divided by 2. Are we cool with how this happened? Okay, some of you don't like that. Okay, I'm cool with that. So are we cool with the fact that this is 1/2 times d to the 1? We're happy with that? Okay. Well, d to the 1 is the same thing as d to the 1 over 1. It's a whole number divided by 1, right? So when now I can multiply these fractions. 1 times d is d, 2 times 1 is 2. So I can rewrite this thing as d over 2, because when I write d to the 1, I just leave that as d. So I'm combining two steps here. The first step I'm combining is I'm going to write d to the 1 as just d. When the exponent is 1, we don't write it. And then the second piece is when I have a fraction multiplied by a whole number, I put that whole number over 1, and I multiply my numerators, I multiply my denominators, so this becomes 1 times d, which is d, and 2 times 1, which is 2, becoming d over 2. Does that help? Do we accept it and we're uncomfortable?
Can you
Perfect.
show another example of how that would happen?
Sure. Danny wants another example. You don't have, so definitely write this one down, both sides. You don't have to write this next one down. I'll just walk you through it. My last example here, Danny wants another one, so let's do, what if I had 12 over 36, 12d to the 7 over 36d squared. And I don't want to write this thing as a decimal. I'm just going to reduce the fraction. Looking at this, what's 12 over 36 as a reduced fraction? Kyla? It's 1 over 3. Because 12 and 36 are both divisible by 12. 36 divided by 12 is 3. 12 divided, so this is going to be 1 over 3. And then the d to the 7 over d squared is going to give me what? D to the 5. And I want to bring these, I want to deal with them as one object. So I'm going to write d to the 5 as d to the 5 over 1, and I'm going to multiply these two things together. 1 times d to the 5, that's just going to give d to the 5, and then 3 times 1 is just going to give me 3.
So basically the one just cancels out.
It doesn't cancel out. Multiplying by 1, you don't have to write. Here it's not canceling. Here we just don't write it because multiplying by 1 doesn't change anything. Does that help at all?
Yep.
See another
I thought
example?
it was different with they both had a 1 in the first example, but then this was a.
Oh, you mean oh yeah, fair enough.
Yeah.
Okay, cool. Okay, do this real fast. Go. Just the first 6 up at the top. I want you to do them. Oh, actually, I lied. Don't do them. Don't do them. We're going to talk about them. We're going to talk about these. Okay, because these things get gnarly. We can start combining these two laws. So, ladies and gentlemen, this first one here is just like we've done before. What is this? 2 to the power of 3. It's just a normal question, just like applying the law that I gave you. But if we look now here down at question number 2, question number 2 is going to combine these two laws. These two laws are allowed to be combined because multiplication and division can also be combined. So how would I deal with this thing? Anyone want to take a guess? Danny?
Do the 3 to the power of 5 times 3 to the power of 6. I give you 3 to the power of 11
Yep.
over 3 to the power of 2. Then it'd be, yeah, then you go from there.
So it's going to be 3 to 9. Yeah. Cool. Done. Easy. Love it. Question number 3 is an interesting beast. We do not have a law. There is no law for added bases. Which means we do nothing. Yeah. Sorry. So there is no expressing this one as a single power. No, we're just done. The question says to express as a single power. We can't. That's it. There is no simplifying here.
Wait,
Actually, you don't want stuff like this on our test because you'll be like, things like this drive students crazy. I'll say the instructions are to do this, and they're like, oh, but we can't, and then that's when they make stuff up. You're going to get something like this on your test. You're going to get things you're not able to do, and what I'm testing you is for you to recognize that there's nothing you can do. But I guarantee you in a test situation, that's going to drive you crazy because you're going to be like, did I forget something or am I not allowed to apply a law? Which is it? And you're not going to like me. And I know that's going to happen. But that's okay. Kyla.
Are we allowed to write negative on this paper now?
Which question are you on?
Let's practice evaluate.
Let's keep going together. Okay, number 4. What am I doing? Here, let's do this bad boy. What's going on here? What do you mean it's not the same? What's the base here? It's A. What's the base here? What's the base here? So I can group those. So what's this going to give me? Let's just do the A's first. On the top I'm going to have, Carolyn? Yeah, negative 3, 8, 8. So then it's going to be over negative 9 times 8. Keep going. So now she's dividing the coefficients. Negative 3 divided by negative 9. They're both negative. So when you divide two negatives, it ends up being positive, and 3 over 9 reduces to 1 over 3. You betcha. Cool. Anyone have questions about any of that? She marched it through perfectly. Okay, now we got number 5. You want a second to think? Sure, I'll give you a second to think. Okay, can I go on now? Okay, so I haven't even started the question, Kyla. Here we go. Number 5. Let's do it. So, does someone want to take? So, Kyla, what's your question about number 5? If I don't tell you that, what do you have to assume? You have to assume that they're different. You cannot assume they're the same thing. Unless I specifically tell you x equals y equals z. But that's not here. So we cannot assume they're the same, and Harwin wants to try it. So Harwin, take it away. So you're dealing with the 5 squared and the 5 to the 5. So it's going to be 5 minus 2, so that's going to be x to the 3. Keep going. You betcha, because 6 minus 3 is 3. You're almost done. Finish it up. What's missing? Yeah, what's left on the bottom? The 18. Okay, so finish it up. Send us home. 9 over 18 is? So I can write this thing now as x cubed, y cubed, z to the 9 over 2. Because the 9 and the 18 reduce to 1 over 2, and I don't have to write the 1. I'm skipping this middle step here. I'm just jumping straight from here to here. So here to here. Yeah, those are all variables. They're just different variables. Good job. Danny.
So, wait, it can make sense. Never mind.
Okay.
Wait. Oh, never mind. Okay.
Who wants to try number 6? Eminent. But can you group anything else? The A's and the C's can be grouped and the coefficients can be reduced. So that part we still have to do. So that you said 4 divided by 2 is 2. Okay, good. Keep going. Which is? Right, because if it's a power of 1, we don't write the 1. Good. Keep going. Right, because nothing happens to it. It just stays there. Yeah. Done. Well, because 4 over 2 is 2. I love it. Good job. Do we all follow what she did? Because there's no work shown. She talked her work through piece by piece. Are there any questions? She reduced the A's, she reduced the C's, and she reduced the coefficients. There's nothing left in the denominator. Okay. Number 7. Questions like number 7, when they say evaluate, the first thing they want you to do is always, it'll say things like simplify, then evaluate. So write it as an exponent, so it's going to be 3 to the power of, it'll be 3 to the 7 over 3 to the 5, which is what? 3 to the power of 2, which is 9. So I want to see both of these pieces. Fully simplified and an evaluated version. Okay, who wants to tackle 2? Anybody? Bed mass is important, yep. What's the base here? Are there brackets? No. The base here is just 5. So this is the same thing as negative 1 times 5 cubed divided by 5 squared times 5. Yes, because this thing is going to be negative 1 times, I can do this division piece. When I'm dividing here, what do I do with the exponents? I subtract them. 3 minus 2 is 3 minus 2 is, and I don't write the 1, so it's going to be 5 times 5. So this is going to be we're going to write this as negative 5 squared first, or negative 1 times 5 squared, which is going to be negative 25, because it's negative 1 times 5 times 5. This piece here is the simplified expression. This is my evaluated piece. Okay, number 3. How do I deal with this beast? Actually, it's not very beastly. It's pretty simple. Harwin. Okay. Can I simplify this further? Do I have a rule for subtracted bases? No, so I cannot simplify this further. This is fully simplified. Now evaluate it. What's this? 2 cubed is? Minus. Done. Danny.
So, since we can't add, we can't subtract either?
Correct, because addition and subtraction are basically the same thing. And then last one here, number 4. Take it away, someone, anyone, literally? Carmen. I saw that hand. Okay. Brave soul. Carolyn. So sorry, slow down. Say it again. Okay, so 6 to the 5 divided, so you're doing it in steps. I love it. Minus 6 squared all over 6 to the 7, 6 to the 5. Okay, keep going. Remember, so she did this. She just did this first piece. So 6 to the 4 times 6 to the 1, she added the exponents that gave us 6 to the 5. She's doing it piece by piece, which is a little weird, because Carolyn usually just gives us a great little final answer, which is perfect. She's slowing it down, which I love. So Carolyn, you gave us 6 to the 5, and then this piece. Now keep going. Yeah, 6 to the 5 divided by 6 to the 4, that's just 6 to the 1, which we can write as 6. So this is going to be 6 minus 6 squared. Keep going. And the bottom is just going to be 6 squared, because 7 minus 5 is 2. I love it. Keep going. This is fully simplified, because we don't have a rule for subtraction. Carolyn, finish it off. There is a way to do it, but you got to be real careful. Because we're adding subtracting rather in the numerator, you got to be really careful how you deal with this. Because Bedmass would say we have to deal with that piece first. There is a way to do it, but I'm going to be willing to bet I would just confuse most of you. Yeah, now just evaluate, yeah. Yeah. Yeah, now finish it up. Keep going. And then the last step is to reduce that fraction. Okay, can you go further? Done. Love it. So that's that. Okay, that's it. So these are the first 2 laws. I hope. So the laws themselves are review, but I'm going to give you questions that are a lot more complicated than the stuff that you would have done in middle school. Your homework for this section is down here at the bottom. I'm going to add 1 question in there. No, I'm going to add 1 more question in there. This is not a democracy. This is a dictatorship. I'm adding in question number 15. For these questions, it says evaluate. I want you to simplify first, then evaluate. Yeah. 15, there is no, 15 is one of those questions where it says find the mistake and then correct it. So 15 is not a simplified then evaluate. For 13 and 19, I want you to do that. I don't know how much time's left. There might not be a lot. Oh, maybe 5 or 6 minutes. Start this. If you didn't do the bed math stuff yesterday, go back to the bed math stuff. And there's a chunk of questions I want you to look at here. May the force be with y'all. I will post this video if there is confusion. You can take a look at this video again.